Built for HTML5, Flash, and native apps with haXe, was presented as part of the Flash in the City conference. This presentation was originally recorded on June 11, 2011, in New York City.
That'll have to do. So, right, just again, how many haXe developers already here? Show of hands. One. Yeah, some interest. Working on it, maybe. Thanks for showing up. Flash developers. Right, the overwhelming majority. Any people who are coming from a JavaScript background, strictly? All right, cool. Thanks for showing up. You're going to like strict typing. It'll really help with those big projects that you're going to get down the HTML5 pipeline. So, let's dive in to this new language. Well, it's not really new. It's about 5 or 6 years old. Quick question also. Is Brooklyn in the house? Anyone? Okay. Stop playing Rihanna all hours of the night. It's terrible. That's me, Jeremy. You can follow me on Twitter. I think I'm shifting back from personal tweets to code-related tweets, so perfect timing, ladies and gentlemen. Right, ActionScript since 2006. I've got a year and a half of haXe under my belt. An important point, even though you can compile to all of these different platforms, which gets most people interested in haXe, like that's the bullet point that we always expected on this slide, but it's very malleable and flexible. The community changes it on a regular basis. Individuals change it on a regular basis to suit the needs that they have. And everybody shares the code that they have because that really strengthens the platform. It also compiles fast. Here we go. It also compiles fast, and it does a very good job at it. The Swift code that comes out of the haXe compiler is arguably cleaner and quicker running than stuff coming out of MXMLC. Although later this year there's going to be a new official ActionScript 3 compiler. We'll see how it compares. There's a lot of Adobe fans, I hear. There's a lot of haXe fans in Adobe, and I would like to think that they're motivating each other to improve that technology. Also, haXe introduces syntax that's not available in all of the languages that are the typical languages for the platforms that it supports, such as strict typing in PHP and JavaScript. And finally, haXe has something, the community calls it batteries included. There are a lot of useful utilities in the haXe API. You can imagine the API branching out, that there's some stuff that's Flash specific, some stuff that's JavaScript specific. We'll go into that later. But there is a haXe package in the API which implements the same functionality for all platforms that are officially supported by the haXe compiler. So when you use that class for one target, it does the exact same thing as when you use it for the other target. Very handy. We're going to look at one of those. Truth be told, I was going to tell you how to pronounce haXe, but I have no authority. In fact, nobody does. You might want to ask haXe users in your locale how they pronounce it, though, before you pick a pronunciation, because there are regional preferences. I would recommend haXe in New York, like Eastern Seaboard, during daylight saving time. But, Roman characters in other locales, you go halfway across the world and you start talking about haXe, and they're going to have no idea what you're talking about.
Is there a text function to get the pronunciation revoked?
No, there is not. But you could propose one. I'm sure the mailing list could really use that one extra email. There's a lot of people who are behind this. Maybe not as many as ActionScript 3, of course, but the community is growing. The mailing list is extremely active to the point that you might want to implement some sort of filter when you ask a question and expect an answer. But that answer will come to you because, that's the general nature of that community. I'm sorry, 1 second. There's a bug. I can see my notes. The mirroring should be on? You mean the mirroring of the display? I cannot turn that on. 1 second. Very well. There we go. PowerFlasher, the makers of FDT, came up with a new logo, which you saw momentarily. What you might not have seen is that it's in 3D, and this is implemented in hex, but it's also a code demo that probably shouldn't entice too many of you. It's, people have been doing this with a 2D API for 5 to 7 years. The question is, can you tell what it's been implemented in? It's in a web browser, but the target platform, it could be Flash, it could be JavaScript. We've reached a convergence of functionality in some of the technologies that we're interested in deploying things to, and it would be useful to take advantage of that. That's the whole point behind hex. Before we get into syntax, I'd like to remind you that although hex is designed to look like ECMAScript, you don't get credit for being a hex programmer by taking your old ActionScript 3 code and doing a find and replace so that everything works, unfortunately. There's some stuff that it takes from Java as well. And, anyone with experience in Java? Okay, you're gonna see some old ground being covered again, which is good. Oh, by the way, if you have internet access, there we go. There is a zip file with all the code waiting for you at this URL. Should I wait for anyone to actually download this? Okay, cool. Thanks for listening intently and having your laptops out instead of munching on street food, which you could totally do. That's an authentic New York activity.
Can you grab the Wi-Fi code here?
Run the what? The Wi-Fi platform? Password. So you're going to want to, I'm not even on the right one. But yeah, if you go to Flash in the Cities network, join the network, show networks. And the password you're going to want is I love FATC, like so. But I'm going to use this one, because I can. There we go. Again, resmason.net/talks/hex FATC 2011. And it's the zip. In there, you're going to find a project. Let's see what FDT looks like at 1024 by 7. Okay, that's doable. Can everyone read that code? Is it large enough, or should I increase the font size? Increase back there? All right. Appearance. Edit. 36. Let's try that. Oh. 18. Better back there? Okay. There's a project in there called Syntax, although I should call it syntax because I pronounce it hex. And as Alan pointed out, there's a main HexML file which contains the details of the project. Again, there's a GUI, but if you want to peel back the GUI, you can go down here to where it says details and source, and you can manipulate the text there. We've only got the Swift target in this one because I'm going over basic syntax. Let me close some of these. Just doing some cleaning up. Right. Oops. Let's start with the type zoo. The types, actually, let's first start with basic commands. You're all familiar with trace, I assume. Trace is like console.log for you JavaScript developers. It spits out a string representation of the data that you stick inside it. Hex doesn't have the rest parameter, so functions like trace that you might expect to be able to accept any number of arguments are not going to behave the way that you might predict them to from a Flash background. If you do want a bunch of arguments to be spat out, you might want to put it in an array. I'm just letting you guys know. Hex interprets trace in the Flash target to draw text, to put text in an on-screen text box. So it's not going to spit it out in the log that some of you might be used to. You can use flash.lib.trace to trace to that, which I can demonstrate later. For now, though, we actually want it to show up. I'm going to double-click this. There we go. It says hi. Something handy about Hex's basic syntax is there's a command called type. Type will spit out the compile time type of the variable that you stick inside it. And because it's compile time, it doesn't actually do anything at runtime. What it does is it produces, so it looks like an error in FTT, but it's actually a warning. And it says warning string. And so we know that hi is of type string. Let's look into some of these types. Go into type zoo. You're familiar with number often representing floating point numbers. This is the same thing in Hex. It's the IEEE whatever. I think it's 32 or 64-bit, whatever. Is not a number is a function on the math object instead of a global, but I assume most of you aren't too worried about is not a number in your code. Anyway, it's simple decimal representation. Ints are capitalized of type int, like so. It'll throw an error if we put in a decimal. If we want to convert a float into an int, we use the int function on what is called the standard library, which you don't have to import or anything. It's just there, just like math. And if we trace integer in this case, we'll get 5. Actually, let me just... If the compiled deliverable of Hex doesn't show up in your project panel in FTT, select your project and hit F5, or right-click and choose refresh, and it will appear again, like so. So actually, we're getting a bunch of stuff out. Let's see, trace integer. 1 second. Just commenting out some trace statements. There we go. Hi, true, 5. Okay, good. uint with a capital U and a capital I is a type that is only accessible by default in the Flash target. JavaScript makes no distinction between integers and unsigned integers. You just use int. If you have code that is supposed to compile to multiple targets and it uses uint, as it should if you're compiling to Flash, there's a reason why we do that. The syntax of the Hex language allows us to override this problem, and we'll see how that works in a little while. But here I go with an unsigned integer, which has got an alpha value, I suppose, or however you want. But yes, this type only exists in the Flash 9 target. Booleans are represented as bool. Strings obviously have double quotes or single quotes. There is a string tools class, which you do need to import. And it has some very useful functions like trimming. I believe there's a trim left and a trim right. Just like in ActionScript 3, you don't get any points for memorizing the entire API, so you're going to want to keep this thing open at all times. String tools, trim left, nope, L-trim, there we go. Stuff like that. There's a lot of classes like string tools that have static functions on them, just tons and tons of these. And there's a reason why it's done that way instead of them being top level or something. And we'll get back to that as well. Let's see, replace regular expressions. Who actually uses regular expressions? Thank you, cool. Some people think it's problematic, but I think it's totally worth it. A literal regular expression looks very similar to the way that they're represented in other languages, except that there's a tilde at front at the beginning. So this is any number of L's and an O throughout the entire string, in case I wrote hello twice or whatever. And so I find that, and with reg.replace of the string, I'm replacing, yes, that's right, hello becomes hey. And I trace that out. And that is, oh, right. That is where hey comes from. All of the type declarations that I have here, so this is how you declare a variable. I should have said that at first. Here's the name of the variable, and here's the type of the variable. You do not need to state the type of your variables in hex. In Flash and in JavaScript, you might think, oh, well, you know, the compiler will figure it out, or in Flash's case, it'll stay untyped, and you'll be able to put anything in that variable. But because hex values strict typing so intensely, what it'll actually do is the compiler will only type that variable once it hits the first value that you assign to it. So if you say, for instance here, var alphabet, let's do type alphabet, it will spit out unknown, 0. Not sure why 0 is there, but regardless, it has no type. If I move this, or rather, there we go. If I move it down, you'll see now it's of type string. What's unique about this is I will no longer be able to put anything of a non-string type in there. So if I try to assign an integer to there, it's going to throw a compiler error. So if you don't want to represent your types all over the place, you don't have to, but it's still going to be type safe, which is really handy for people coming from a language background where they don't type things all over the place. The object type in Flash has no explicit equivalent in hex. If you want a dynamic object, you're going to want to type something dynamic. For instance, object of type dynamic can store things of various types. This is a literal object, something that we might be used to, but it does have a type. Its type is name of type string, or maybe dynamic actually, and UID of that type dynamic. Let's try that. Type this literal. There we go. So it did type them. UID is of type int, and name is of type string. Now you know. So it's that easy to figure out, you know, if you've got these weird types sitting around, how to type them. Name and value. Right, so object representation, this is exactly like it is in JavaScript and ActionScript 3. JavaScript and AS3 are unique in that they have, what are they called? First class functions? Is it first class? I think so. Functions are first class objects. You can pass them around. If you have something that can be called, you can hand it to some other code that expects a callable thing that will then call it, rather than these, you know, rather than the alternative. Hex takes this one step further. This is a function. Sup is a function. It accepts a function that takes nothing and returns a string. So because, again, hex does all this strict typing, it expects you to strictly type your function variable containers. For instance, what's up is this static function down here. As you can see, it accepts no parameters, and it returns a string, which is why it says, oh. I think you guys know what's going to come out of here. Another interesting thing about haXe is the way that you can string keywords together. I've been told that this works in more languages than most people think, but this isn't breaking any rules. I've got a return if p. So first of all these variables exist in the scope because I have them here in the parameters. But return if p a, else if q b, else c is the if statement with return values in the middle. There's really no need to write it out entirely. So you can take a bunch of shortcuts. And you can also take a shortcut here. You can declare a function in line, or however you want to call this. That might be handy if you very quickly need to create a utility function to test the behavior of your code if you're debugging something. Keep in mind that the flex type debugger is not available here. Although in the project XML, you can choose to add debug info so that when you get an error, it will tell you what line and character that error is coming from. Again, strict typing. Array objects have to have a type. So here's an array of type string. You can't put non-string objects in there. When you iterate over a typed object, or rather when you iterate in general, this is a lot like Java's for loops and iteration, where you have an iterator. String is a value that's declared here, and every time it loops, the value of string changes. But what's going on in the background is the array class, which I can actually pull up here. haXe. Here we go. Array. Iterator. 1 second. Hide that. Change the font size. 18. So here we're actually looking in the source of haXe. Oh, it's not implemented here. Regardless, iterable objects that you can iterate over, which is just an interface that you can implement in your own code if you want, simply produce an iterator object which has two functions. The next function, which returns an object of the type of that iterator. In the case of an array string, it would be of type string. And hasNext, which returns a Boolean value to determine whether or not there is a next value, which makes it very easy to create your own data structures that you might want to iterate very easily over. You can also create your own iterators very easily, regardless of what you're iterating over. I've got a good example of that. Maybe down here. Yes. Here's an iterator called Hailstone iter. I guess I could say implements iterator. Oops. Implements. Regardless. You can have multiple classes in the same document as long as you have one main class that matches the name of that document. So in here I've got two documents, and main is this class. I don't think I ever even instantiate it. And it contains all of these static functions that we're running. And I have this helper class down here. This class is accessible. If you import the main class, it'll import all the helper classes as well into other parts of your code. By the way, does everyone follow any questions so far? Things I can clarify? Yeah.
Is there a packager for hash classes that folders? Do you package them like you do an ActionScript?
Yes, so packaging is very similar to packaging in ActionScript, packaging in Java. So the main class is in the default package, right? Sort of like package. Right. The package declaration goes at the very top. Like that. Right. So it doesn't do that open and close curly brace that ActionScript 3 does.
You also mentioned that arrays are strings.
No, array string. So I declared an array that stores strings. So this angle bracket syntax says that we are typing the array storage, right? So this is a type. Array string is a type. string is a type, we are incorporating it into the array template. That's what it's called. So you can create classes that do this templating as well. ActionScript 3 sort of has that syntax with vector objects, which came out in Flash Player 10, where you can declare a vector of a certain type, but now you can implement your own classes that do the same thing. Right, so this iterator is passed an integer, and because it has a hasNext function and a next function, whatever math that it does, this is based on a Wikipedia thing of the day or whatever, it'll generate these numbers until it's told to stop. It's called Hailstone. Here we go. So here's a for loop for I in new Hailstone iter, and I throw in a random number, and then I trace hi, which is where all these values were coming from. Point is, you don't need to iterate necessarily from 0 to 10 one by one. You can choose the rule that is used to iterate over the elements that are being generated. And you also don't need to iterate over an iterable. You don't need an array to loop over. You can just put a rule in an iterator, and it will spit out the values that you want to iterate over based on that rule. And also, you can take your time, right? You don't need a for loop necessarily. You can call next and hasNext in your own code to get the next value in that sequence. The sequence never has to end either. You'll notice that there's no declaration of the maximum value in the sequence. Like, you can put one in there, right? I could add a value here, a variable here called like var end of type int. And I could even say max int. And then in here, end equals max. And then maybe that end would represent the end value of the iteration or whatever. But that's not a requirement for the implementation of an iterator. It just goes until you tell it not to. A for loop simply runs until hasNext is false. That's all. Hailstone iter. A bunch of friends and I went to Washington, D.C. in October, and I think some of them still owe me money. I used the hash type, and I templated it with the float type, and I created a new hash of float. ActionScript developers and JavaScript developers might be used to creating objects that use string keys to tie to certain values, and that's what's going on here. So instead of using an object to do that stuff, you might want to use a hash. The hash is simply a set where you can look up values based on string keys. The dictionary object, which Flash developers might be used to, does not exist in haXe. Because haXe needs strict typing, they actually re-implemented it as types dictionary. It's in the same package, flash.utils, but you can you can give a key type and a value type, so that, again, you get the strict typing for the keys that you put in and the values that you get out. So that's the type zoo. Any question about haXe's basic types? Yeah? Actually, I don't even need to import it. 1 second. We all know this trick. This works in ActionScript as well. Let's see. Var dict type typed dictionary. And you're wondering about this bit. I'll use int. Actually, int is stupid. I would just use an array. Why don't I use, for some reason, I've got hash float. Like, this is why I use dicts, because you got these really weird keys and really weird values. So that's the way it would work. That's how you would type something in multiple, Now, when you do this with a class declaration, like, say you're creating an array implementation, like some sort of list of your own that contains things and iterates over them in a special way or whatever, or it's a data structure that's particularly unique. Maybe you're experimenting, and you want the types that are stored to Sorry, let me start over again. Say you're instantiating an iterable, a template class that accepts a certain value. And you want that value to not just be one type, but you want it to be a couple of types. You want it to be an overlap of two different types. You can say var array float int. Or not. Redacted. I'll look back into that. That also might be a little deep for this talk. Moving on. So that was the type zoo. How many of you would consider... Oh, sorry, go on. You can use dynamic in typing, yes. Dynamic exists because even though haXe is a statically typed language, a lot of the platforms that it targets have dynamic type representation. And so it has to include that. For instance, if you scoop up a JSON object from the JavaScript platform, assuming that the JSON wasn't generated from, wasn't interpreted by hex code, say you're using a JavaScript library to generate that information, there's no guarantee that anything is going to be typed. In fact, nothing's going to be typed. It's coming from JavaScript code. So there's no type at runtime. You're going to have to store it in a dynamic object. You can try to cast it, which we'll look at later, to try to type it, but there's no guarantee that it'll work. And by guarantee, I mean, if something doesn't work and it's guaranteed not to work, you're going to get a compiler error. The errors that are going to show up happen before your program even runs, which is ideally where an error is going to show up. That's the whole point. Good to know, thanks. I guess you all consider yourselves object-oriented programmers, generally. If someone asked, you'd be like, yeah. This is being recorded, so there might be people who don't know what object-oriented programming is, or they might use objects but not classes and interfaces in the case of JavaScript. So I've got a fun example down here. I've got a pitcher of beer, which I'm serving from a pub object, pub. Down here is pub, so that's the main pub class. All the other ones are just associated with it, and so they go in the same file. And there's a serve beer function, which is static, meaning I don't need to create a new instance of pub to access this function. It is on the class. And it returns a pitcher. So it creates a new one, and it fills it up, like so. Actually, it sets its capacity and then fills it up and returns it. And then, let's see. It says the number of ounces left. Oh, no, it doesn't. Hang on. I've got to reopen it. Here we go. 30 ounces left. I create an array of tumblers. Tumbler, again, is in here. There's something in hex called a typedef. A typedef is a bookmark to a type. Say I have a type like... maybe I don't have a good example. Typedef. Here we go. Say I have a really, really long type that I don't want to type more than once, right? Like Flash accessibility implementation. Like this is an important one, you know? People who, yeah. So when you use it, you might want to call something shorter. This also works if a type is being templated. So if you have an array of arrays of floats, and you don't want to write that over and over again, you can write float matrix by using a typedef. Typedefs are also good for attaching to things called anonymous types, and we'll look at that after this example. So typedef tumbler. So there's really no important difference between a tumbler and just a glass. I have a glass up here, which implements iGlass. So, right, a class is a bunch of properties and methods that you can instantiate instead of having them in the prototype of an object. It's explicitly stated, so when you create instances, they are guaranteed to have properties of these types. This is a getter. So hex has getters and setters much like ActionScript does. However, they look like variable declarations because that's what they should be like. Size, by default, is just a variable. So whenever we look for the size of a glass, it is going to just behave as if it were a variable. But we're not allowing it to be set outside of this class. So when I say null here, I can still set the size inside this class. but outside the class I'm not allowed to. Implements eyeglass means that the methods and variables that are on the eyeglass interface, which looks like a class except there's no implementation, are forced to be implemented on the glass class. So glass implements eyeglass. Wherever we have eyeglass as a type, we can store a glass in there. Fill. One class can extend another class, meaning that it has the same behavior, except maybe you can change that behavior or you can add behavior to it. For instance, a pitcher can pour the stuff inside it into another one. Ounces equals container.fill. And so that should, let's see, where was that? Tumbler. Here we are. So I have 4 or 5 tumblers. The last guy killed it. He has to fill it, which is too bad. Hex does not have truthiness. If you say if 5 in hex, you're going to get a compiler error because 5 is not a Boolean. We're used to truthiness. We're used to saying if not object. And if the object is null, or if the object is undefined, or if the object is 0, if the object is false, then it would always be false. Well, that doesn't exist in hex. Because everything is explicitly stated, including the expressions themselves, you're going to want your expression to evaluate to the type of the thing that is expecting it. So if you have a Boolean, you can't put an integer in a Boolean. It's not going to evaluate it to true or false. That's not too bad a deal. In fact, it's kind of nice, depending on how you look at it. Oh, God. Okay, so maybe you had one beer too many, and here is the details of your escapade. I created a bad idea object down here. It's not a class, it's an enum. This is right out of Java's textbook. An enum is an enumerable type. There are only 6 bad ideas. I can't create a new bad idea. It's only one of these 6. So I got drunk dial, ugly hookup, brawl, insult bartender, property damage, and overspend. And so I can, drunk dial, you can imagine this sort of being like a constructor, except it's not a constructor. It's referring to an enumeration in the enum type. And I'm passing in, this is actually kind of unique to hex. So these guys are kind of typical enums. But you can associate variables of certain types, almost properties, to an enum representation. So when you go in here and drunk dial Marcy and ask how the kids are and whether they still mention you, that information is going to be accessible when you access this enum declaration, this enum representation in the escapade array. It's not like these are strings. Like when we try to do this in Flash, we tend to use unique strings to represent the different event types or whatever, right? Like that's a classic enum implementation in Flash. But there's no guarantee that it's unique, right? In this case, the compiler is guaranteeing that these are absolutely unique. It doesn't guarantee that they are associated with one another. And it definitely doesn't do this property trick where you can put information on there. So let's iterate over this terrible night that you had as you woke up. Switch statements in hex that have cases for an enum are unique if you leave out default. You know how switch statements can have a default value? If you leave out default, let me comment this out. You'll get a compiler error saying you haven't handled every case in the enum. And that's kind of handy because in some situations you want to handle every case that an enum can be in. So that explains, yeah. Object-oriented programming and alcohol can be abused with awful consequences. Please use both responsibly. Just letting you guys know. I mentioned anonymous types before. Recompile, refresh. There we go. An anonymous type is a type with no implementation. It only exists in compile time. You can declare a type, and maybe you look in your Swift code, in the Swift tags, or in the JavaScript later on, and you're not going to see it anywhere because it only exists when you're compiling. So what good is it, right? Well, imagine you have a point, like a flash point, right, which has an x and y value, obviously, and you have a sprite, which has an x and y value, but a bunch of other things too, a blend mode, a list of, like get child at functions and stuff like that. But you want to find the distance between these two things. So you create a distance function, and you can pass in to what? 2 points? Well, that doesn't allow you to pass in the sprite. 2 sprites wouldn't allow you to pass in the point. But you can create an anonymous type like, let's see, like this one. So this is anonymous. Nope, hang on. New sprite. Here we go, coordinate 2D. Here we are. So I'm using Typedef to sort of snag this anonymous type. Otherwise it would sort of float away. Because these anonymous types don't need a Typedef in order to exist. You can just, put them like var a colon and then just put the anonymous type right there. It's just not generally a good idea. So coordinate 2D simply says whatever object is stored here has an x float and a y float. And what's nice about that, here we are, is you can store a sprite or a point in Chord, even though they don't, they don't subclass the same thing. Like they subclass objects, but they don't represent the same data. They're two distinctly different objects. And here we can, at compile time, represent them as two things that we can maybe evaluate the difference in space between, right? So that's pretty handy. What's this? Right. Here we go. So typing coordinate, we'll say coordinate 2D. So the typedef only exists at compile time, but that type is available if you're doing type, if you're using the type command. If we type object, here we go. Object is going to say that this is the type, which we saw before, because we've got the anonymous type right next to the colon. When you've got similar objects in different compile targets, you might end up using the same typedef to represent them differently because you can call the same variables and functions on them later on. We'll look at that right after. There we go. Any questions about these basics? Yeah. No. So for each is basically iteration, right? Where you generate a variable that stores the information and every for loop in hex basically does that. If you say for I in 0, ranges. ... Nope, 4. Here we go. You see this for loop? It says for I in 0, ... array.length. I is going to be an integer in this case. There's a built-in iterator type that is generated from this code called an int iter. And it does exactly what you expect it does. It has a beginning, and it has an end, and it iterates one by one through those. Maybe you don't want that. Maybe you have a vector of RGBA values that you're passing to like some sort of render code, and you actually want to iterate over like every 4 or whatever. You'd create your own iterator that basically does the same thing. It starts here and it ends there, but it plus equals 4. So that's the sort of thing that hex will allow you to do. So yeah, there are these ranges. So this is more or less a classic loop. But again, it's all iteration. It's all basically the same in that case. Any other questions about basic syntax? Got like half an hour left. I should probably zip through this stuff. All right. Back in. Even if you're not, there's no obligation if you're using hex to target multiple platforms. But you might want to prepare yourself for that scenario, because oftentimes you have intellectual property represented by code in a certain syntax, and someone tells you, oh yeah, we'd like to port it to XYZ, and you're like, oh god, I have to rewrite it again. Well, at least with hex you have the same syntax shared with all these different platforms, but using some certain principles ahead of time, with a little bit of planning, you can avoid most of the difficulty that is involved in that sort of process. First of all of your code that is platform specific, you should probably put it in low-level classes that get the job done and don't try to do too much. The application-specific code, the stuff that gets the job done, the stuff your client requested or whatever, is going to sit above that stuff and is going to be platform agnostic. And by that I mean it will have no idea what platform it is actually running on when it is running. Does that make any sense to you guys? Because that's the stuff that you're going to want to keep unique, and the low-level stuff is stuff that you might adapt when you go from one platform to the next, or if you are building a library to, over time, make it easier and easier to compile to multiple targets. The API is rich, as I said, batteries included. Functionality that you might need in the platforms that you're targeting might already exist. If they don't exist in that API, you can look for libraries that the community has made available, or libraries that other communities have made available. Because remember, each platform that you're targeting has an existing community of people who are writing libraries. Although your assets should be platform agnostic as well. So instead of using a Swift to store animations, you might want to try to find either a vector representation that can be used in JavaScript, which is kind of ugly to think about, I know, or to do what most people are doing and create a sprite sheet system, or use somebody else's sprite sheet system to allow those assets to be more flexible. Because as powerful as the platforms that you love are, if you're thinking of looking past them, then you're going to want to be prepared for that, right? Speaking of libraries, haXe comes with a library manager called haXelib. Can you guys read this? I should probably increase the size, change 18. There we go. There we go. It's a library manager, and it comes with these commands. So haXelib info physax. There we go. One of my favorite libraries. It's a Lightbox 2D implementation that is hex native, and it runs on everything that haXe can target. It's made by the same person who produced haXe, Nicolas Canas. And if you want to install it, it's as simple as install physax. Now, I already have it installed, right? If I wanted to remove it, well, you get the idea. That's a very quick and easy way to get some of the more common libraries on your system. It's not going to grab the code and throw it into your project. It's going to grab the code and put it in haXe's home on your machine, which is usually buried deep. But then if you use this syntax in blue, libphysax, for instance, in your compile, like as a compiler argument in your HexML, then immediately that library is going to be made available. Libraries can also contain code that gets run during compile time. There's some really complicated libraries, one of which we'll look at later. Some libraries are platform specific. They're not implemented in haXe. They're implemented in JavaScript or ActionScript 3 or whatever. And in those cases, you're going to want to create these bridge objects, these extern classes. An extern class looks like a normal class, except it has no implementation. If you have JavaScript that resembles... here, hang on. I have a perfect example of this. In here, externs container. Here we are. So you use the extern keyword in front of class, and these classes can extend and implement other things all you want. These classes are going to exist at runtime, so they're going to be represented in the final deliverable. And as you can see, I'm just completely leaving out any implementation. But also, these types aren't things that are guaranteed necessarily by the JavaScript code that this connects to. I'm establishing rules that I know the program should follow when it is run. So you can strictly type things that you are used to using in non-strictly typed languages. And when you write this once, you can generally write it, you can generally reuse it multiple times. You used to have to do that with Flash, but if you think about it, Swifts and Swix already contain all the strict typing that you might need, except for functions, but then those get typed as dynamic. So the haXe platform also has the swiftlib argument, which will just grab a Swift and generate those extern classes for you, which is kind of handy as well. Please be aware, anytime you use a library, someone's probably licensed it with some rule or other. If you're licensing your code one way, or if you're using a bunch of other libraries that are licensed in a certain way, you might not be able to use the code that you want, and in which case you'll have to look elsewhere, which is unfortunate. But that's generally what happens when you start working in a community, right? That tries to share things. They try to set rules about how it can be shared. That's a consequence. If you're targeting a browser, there are a bunch of ways that you can represent things on screen. And let's face it, the hardest challenge for people to do cross-platform implementations of the same idea is the view, right? haXe already handles the syntax. It's pretty easy for us to avoid platform-specific stuff in the brainy, non-visual part of our code. If you have a Flash version, if you have a Flash-targeted haXe project with code separated the way that we talked about, the application code is already going to be available for the other platform. You just need to write that low-level code in order to support it again. There are pros and cons to all of these different technologies in the view. Generally, haXe developers tend to look at the canvas tag because it is so similar to the graphics API in Flash. There is a library that I use in that 3D logo demo called Easel.js, developed by Grant Skinner. It's in JavaScript. And it uses the canvas, but it uses the matrix concatenation features of the canvas to pretend that it has a display list the way that Flash does. So he creates these persistent objects that represent graphics that you don't have to redraw over and over again. You just say what they look like and you put them on the display list the way that we're used to in Flash. Webgl has a lot of promise. You guys know about Stage 3D. Flash is going to have this 3D API soon. You can also use that to do 2D rendering, and in many cases, that's going to be a better idea than using the default display list because it's going to be graphics processor accelerated. Webgl is also GPU accelerated, and a lot of the other targets that haXe can a lot of the other platforms that haXe can target have something similar to OpenGL. It seems like there's going to be some convergence. We might see a batteries included implementation of a display list within the near future, once these things get matured enough that we can write the haXe packaged code that targets all these different platforms at once. In the meantime, though, there's going to be features that aren't present in the platform that you want, right? For instance, Angry Birds for Chrome is an HTML5 application, but all of the sound is generated through a small SWIF that is in the corner of the, in a corner of the browser window. And so you're always going to want to be able to use the platforms that maybe you're moving away from in case the browser doesn't support or have consistent support across browsers for the functionality that you want in your platform. Fortunately, it's pretty simple, as we'll see, to write code that allows for JavaScript and Flash to be bridged in the browser. You're not limited to one of these. You can pick any of them. I have a game that draws a really complicated image, but it also has a user interface that's laid out pretty much like a typical web page. And so for the JavaScript target, I might actually put a canvas or WebGL in here for the board, and the user interface might be in HTML and CSS because those are the strengths and weaknesses of those different rendering techniques. So, don't feel like you're limited by any one of these. Did anyone guess what this was implemented in? Who thinks it's Flash? Who thinks it's JavaScript? Who thinks I'm pulling your legs somehow, but you don't really know how I should get down to it? It is in both at the same time, JavaScript on the left, Flash on the right. And it's completely consistent, except for an occasional timing issue where they redraw at slightly different times. They have the exact same behavior because there's convergent functionality. We should be taking advantage of this. The code that separates them obviously isn't drawing to the canvas or something. It's actually separating two different divs. So there's a canvas on this side, canvas tag, there you are, canvas. And on this side, we got Flash player in a div. All of this is handled by the same basic platform. Let's take a look at that. It is called Hexagon. The main hexagon class, I just realized that I overlooked something. You see this using keyword? This is extremely powerful. The reason why Hex has so many utility classes that just contain static functions is because of this using keyword. It's actually called a mixin, the using mixin. What the using mixin does, if we go into draw3d.hex, and we look at a function called like project, here we go. Public static function project. The first parameter is a point, the second parameter is a float, and it returns nothing. If I then look for the project function in hexagon, where the using keyword was used, you'll notice that it looks like project is a method of an object. This object's type happens to be point, and it only has one parameter, which happens to be float. What using does is it takes a static function on the class that you're using, and it allows you to pretend as if it is a method on the type of the first parameter, and then it just accepts the rest of the parameters. This is super awesome. Let me show you. In Draw3D, using math, .min, no, .max, .abs, hang on. Do I not use math? Here, I got an idea. I'll comment it out and see what's wrong. Nothing. POW, that's right. T.pow exponent. So T is a number, and I'm acting as if it has a method pow, which represents the power to put it, to place it to, and I throw in the exponent rather than math.pow first value exponent. It just seemed natural in this case. Renderer probably does it as well. Whoops. Using math. No? Oh, but it's using something. Using standard. Int. So instead of using standard.int and then you pass in a float, you can just have a float and then say .int. What most people don't think about with this feature when they first discover it is that you can have a bunch of types. And remember, when you do using, it's not like you're actually putting the methods in those classes or in those types. You're just sort of imposing them during compile time. At runtime, it's a static function just like it used to be. So you're not going to get like a performance increase or anything like that. It's simply syntactical sugar. But say I have say I have a method that I want to use on points, and I pass it a point and then the other parameters, and then I call using. Maybe I don't want that in every context. Maybe I have another context where I want another bunch of methods and utilities or whatever. I can call using with this context when I need this one, and I can call using with this context when I need that one. So I'm not weighing down the class that the functions are pretending to be on with these various implementations. So you can keep your classes light, and you can put all your methods on classes that represent like the context that you're processing data in. It's very powerful. Anyway, hexagon is a class. It has very little. Here we go. Here we're seeing a fork where one compile target does one thing and the other compile targets do another thing. This is handy. Hex's package has a Firebug trace redirector, so that when you have Firebug open in Firefox, it'll show you the tracings. You'll have to take my word for it. We're a little short on time. In both of these cases, I'm waiting for the initialization of the rendering system, right? I'm waiting for onload in JavaScript, and in Flash, I'm waiting for the loader info to say init, and I call init down here. It's static. Here we go. Say you want to pass parameters into your code. You can fork it thusly. First of all, I'm typing it as dynamic. I'm not really bothered that it doesn't have a strict class. If you want to sort of break Hex's rules, you can use untyped, and it's just going to ignore the strict typing of things. And underscore, like this JS function, basically takes a JavaScript value that you have in quotes, and it evaluates it and it puts it in place. So that's kind of powerful. It is basically like injecting JavaScript into your hex. You can't do that in Flash, obviously. We know where the parameters are in Flash. They're on the loader info object. And then we create a new hexagon, and we pass it in the parameters. It's dynamic. Oh, right. Just like Java, Hex has that main static class as the entry point. It always has to be there in the main class. But you don't have any other limitations necessarily. Beyond here, everything else is platform agnostic, like everything past this. But here we're basically grabbing the base display representation and we're passing it to the renderer. The renderer is the lower level class. That's the one that does all the dirty work. We're going to see if.js, else stuff all over there. But that's because we want to keep it out of these higher level classes. So all the rest here, you can see, is platform agnostic. It's not pretending to be one platform or another. It doesn't have to. In the renderer, we're importing some things if it's JavaScript. We're importing other things if it's Flash. There are things you can't import, like if you've got a JavaScript application, you try to import a Flash package, it's going to throw a compiler error. So you need to use these compiler conditions. Here I have base being HTML DOM, which is how Hex represents document elements in HTML. Down here in Flash, base is a sprite. It just seemed to make sense at the time. And in here I have graphics as Flash display.graphics. But in here, I'm using Easel.js's graphics object, which deliberately has the same graphics API. So you can just, you can basically sort of masquerade things to be the same using these typedefs. And if.js, etc. This is where the dirty work is done. I don't feel like I really need to detail this stuff because, frankly, you guys can be using any API, right? It doesn't matter whether I'm showing you Easel.js or someone's implementation of a Hex library for Webgl, or maybe you're writing code that goes into Flash Professional. It has a JavaScript IDE, right? Like a JavaScript tie-in. So there's really no point in detailing the API calls, just that if you can use one API for one platform and another for another platform, how to diverge. So that's basically what we're doing here. That's all that's going on. But you try to consolidate that into one low-level class. Any questions, by the way, about this stuff? Yeah? You can, yes. Let's see if I have anything like that. Override. Yes, in fact, the trick that I pulled on you guys was that I created a subclass of hexagon called Hexenstein, and it extends hexagon, and it adds the communication logic so that the two things behave the same way. So in this case, I had a function. By the way, the private namespace in Hex is like protected in ActionScript 3. This is just like in Java. A subclass of something that is private. A subclass can reference. Sorry? Yes. A subclass can access private members and properties of a superclass. If you want to prevent that, if you want to prevent overriding, you can say final. If you want to override someone's final, you can say hack. So again, like, what are you trying to solve here? But yeah, so it's override, much like in ECMAScript. How are we doing on time? Okay. I'll get back to these slides then. So Hex's remoting is included. It's a batteries included feature. It's built in. It allows you to communicate between all your different targets. One of the targets that Hex has, am I doing all right? All right. One of the targets that Hex has is called Mecha Vm. It's one of the first ones. It is a virtual machine like Flash, except it's extensible. It's not completely locked down. You can plug in. Here we go. With these NDLLs, these dynamic libraries, you can plug in functionality that you want, which is really handy. So you can use Mecha Vm. As long as you know C++, you can use it for whatever you want to create like the virtual machine that you always wanted. It comes with Hex. It's part of Hex. Hex uses it to compile some things sometimes. You can run it as a server with a module that you plug into Apache called Modneco. And it comes with a tool that allows you to create standalone applications for your platform from the scripts that you compile for it. It has its own community, it's its own thing, just like Flash is its own thing. But it is made by the people who made Hex. I already showed you some remoting, so I'm going to have to skip that. Sorry, guys. What I did want to show off, though, is the following. 1 second. So, why would I bring up Mecha Vm? I guess most of you probably don't think you're going to compile to Mecha Vm, right? That's the thing. Native code, like C++ code, can't rely on a runtime, right? Can't rely on an application framework to get the job done. People say, you can target this platform with Adobe Air. We're trying to step away from that. Native code in Hex that uses the C++ compile target relies on Hex. Here we go. So it just compiled C++ project. So this is a separate XML file. FTT has a little bit of trouble with the C++ target, but that's understandable because it's a little strange. My Mecha Vm, which I have installed on my machine, has the NME module plugged into it. And NME basically tries to include all of Flash's functionality into Mecha Vm to some degree. It's not a perfect fit, but in some ways it's necessary. This is how you create Android and iOS implementations of your Flash code. Instead of writing C++ specific code all over again, you can use the remap argument, which is going to replace all of the references of Flash in your packages with NME. And so what happens as a result, C++, hexagon. Here we go. So this is native code running on my machine. You might notice that it's not as anti-aliased as Flash's was, but it has all the same functionality, right? I didn't have to rewrite it the way that I did for JavaScript, or that low-level code anyway, because it is pretending to be Flash. It's not perfect. It's a good idea to begin doing remapping as soon as you can in your project, as early as possible. But that is the way that you compile to multiple targets. Like that. So using NME, oh, whoops, hang on. There we go. So by compiling to Neko, using the NME remap, you can create a Mecha Vm object, which the C++ target then generates native code for. And it supports Mac, Linux, Windows, Android, and iOS, although some of those are always more difficult than others. The further down this process you go, the more difficult the thing is, essentially. I'm going to fast forward through this because I believe I am more than running out of time. Quick mention, there are people working on a Java target and a C# target so that native Android can go through a different way than just C++, but also JVM. Sorry, not C++ target, C# target. In order to support Unity as a target platform. I'm not entirely sure how this would work, but there's already a draft for it. And these are also the people who are hopefully going to make a unified view so that we can all implement our graphics using one single library instead of having to do the compile stuff. Every part of Hex is extensible. Instead of being a SWIC that comes with the compiler, all of the code you can dive into and change. And then you can even share those changes. You can say, my version of the Hex library is better for X, Y, and Z. And maybe that'll benefit somebody. Because remember that Hex is a giant gift that somebody gave to you. It's a compiler that compiles to multiple runtimes. It eases the politicization of the industry that we're in. The libraries are someone else's gift. The macros, which, for instance, the shaders and the meta-programming tools that people have created for the platform, these are all somebody's time. Whether they were paid for it or not, they're giving it to you for free so that you can make stuff on your own time. And if you create your own stuff that gets you further than when you started out, it just seems like a good idea to share it with the rest of the community. Anyway, these are some people who contributed. And if there's something that I didn't cover or something that you have a unique question about, flag me down. I'll answer any hex questions, especially because I went over. I sort of owe it to you guys. Thank you for your time.